Hi, I'm Kathleen Hupfeld. In this video, I'll briefly review information about how we can use transcranial magnetic stimulation, or TMS, to collect cortical silent periods, or cSPs. A cSP presents as a reduction or silence of ongoing muscle activity during a voluntary muscle contraction and provides information regarding intracortical inhibition. cSPs thus give us insight into how the central nervous system controls muscle activity and the role of inhibition in the neural control of movement. For detailed information about all of the steps needed to set up a TMS experiment targeting the motor system, please see my longer TMS demo video. In this video, we'll focus more broadly on the general experimental setup for cSPs and discuss what cSPs are measuring. Our example setup here shows measurement of cSPs in a hand muscle, specifically in the FDI, or first dorsal interosseous muscle. The general setup includes having the subject rest one hand muscle. In this case, their right hand is resting or relaxing. And the flat red line here is showing the EMG activity in their right hand, or the electrical activity in that hand muscle. Since they're resting the right hand, there's no visible EMG activity in this red trace. Next, we ask the subject to contract the opposite hand muscle at a low level of force. In this example, they're contracting the left hand at 15% of their MVC, or 15% of their maximal voluntary contraction. The blue trace here is showing the muscle activity in the left hand, so you can see that this hand is actively producing force. Then, if we look at the brain, this left hand contraction is observed by the primary motor cortex contralateral to the contracting hand. So here, the right primary motor cortex is supporting the left hand contraction. Next, while the subject continues to hold this low-level contraction with the left hand, we apply a TMS pulse to the active primary motor cortex. Almost immediately, in the EMG activity, we can see an MEP, or a motor evoked potential. This is shown in the yellow box. MEPs are essentially a measure of excitability of motor neurons. More specifically, MEPs are spikes in the muscle activity that result from volleys of action potentials along the corticospinal tract. Usually, but not always, the MEP is also accompanied by a small twitch that you can see in the hand muscle. Next, in response to this external TMS stimulus, we get an influx of GABA within the active primary motor cortex. GABA is the primary inhibitory neurotransmitter within the brain. This GABAergic response briefly disrupts the descending motor signal and ultimately causes a short silence in the EMG activity. This is your cortical silent period, or cSP. You can see the silence in the unrectified EMG in bright blue and in the rectified EMG in the red box. This silence typically lasts for about 50 to 200 milliseconds, and then after that period of silence, regular EMG activity resumes. So essentially, this cSP, or cortical silent period that we've elicited, provides a measure of the motor system's functional GABAergic response to the TMS stimulus. To obtain a quantitative measure of this functional cortical inhibition within the motor system, typically, researchers quantify the duration and/or the depth of the cSP. And commonly, researchers will elicit many cSPs per muscle, like 15 to 20 or more, and then, for instance, calculate an average duration or depth over all of those trials. That concludes this overview video. I hope that you found it to be helpful. If you have any questions about the topics discussed here, please feel free to contact me via email or Twitter. And for further information about setting up a TMS experiment and collecting cSPs, please see my TMS demonstration video, also located on my YouTube channel. And for reading on methodological considerations for cSP experiments, please see our recent publication in the Journal of Neuroscience Methods, which I've linked in the description of this video.